Hello, I'm Svetlin Nakov from SoftUni, the software university. Together with my colleague George Grigiev, we shall teach this free Java Foundations course, which covers important concepts from Java programming such as arrays, lists, methods, strings, classes, objects, and exceptions, and prepares you for the Java Foundations official exam from Oracle. This lesson aims to review the basic Java syntax, the console-based input and output in Java, conditional statements in Java such as if, else, and switch case, loops in Java, for loops, while loops, and do while loops, and code debugging in IntelliJ IDEA development environment. Your trainer George will explain and demonstrate all these topics with live coding examples and will give you some hands-on exercises to gain practical experience with the mentioned code concepts. Let's start! Before the start, I would like to introduce your course instructors, Svetlin Nakov and George Grigiev, who are experienced Java developers, senior software engineers, and inspirational tech trainers. They have spent thousands of hours teaching programming and software technologies and are top trainers from SoftUni. I'm sure you will like how they teach programming. Let me present you the course trainers. The first trainer is George Grigiev, who is senior technical trainer at SoftUni. He teaches C++, C#, Java data structures, and others. He's an award winner. He's a very experienced software engineer working for big names in the software industry, and he's very experienced developer, currently working in a startup about racing cars and telemetrics of these cars, where he writes Java, JavaScript, and C++, and he has more than 6 years experience as instructor and more than 12 years of coding experience on many projects, and he is keen about C++, physics, and more complex problems, not just simple web apps and front end and back end. And George is really nice to see person who is explaining complex concepts in simple way, and who is also explaining with fun, with some interesting style. So I really think that you will like him. And me, I'm a software engineer, a technical trainer, entrepreneur, and inspirer for tens of thousands of students to start coding and to learn programming and get a tech job. I'm a PhD in computer science, a book author of more than 15 titles, mostly tech books about C#, Java, JavaScript, and Python programming, also about web apps, cryptography, and many others. I'm a founder, the main person behind 3 successful tech educational initiatives, which were attended by more than 350 students, the National Academy for Software Development, the Telerik Software Academy, and SoftUni, which is the largest tech education provider in the Southeastern Europe, where we teach a lot of students in programming and give them profession and job in the software industry. So I'm the main person behind these training initiatives, and I really love to teach developers, and I really enjoy when the people who I show how to program, learn programming and start a job, because I do this constantly, and this is my mission in the life. So we, together with George, will teach this course and we'll be happy to teach you in the Java Foundations and to prepare you for the Oracle Java Foundations practical technical exam. Let's start. This first lesson aims to briefly go over the material from the Java Basics course and revise the key concepts from Java coding. If you have basic experience in another programming language, this is the perfect way to pick up on Java. If not, you'd better go through the Java Basics full course. We'll go over Java Basics syntax, input and output from the system console, conditional statements such as if else and switch case, whoops, like for, while loop, and do while, and debugging and troubleshooting Java code. If you are well familiar with all of these concepts and you don't need a revision, feel free to skip this section and go to the next one where we talk about data types and type conversions in Java. If you don't have significant experience in writing Java code, please solve the hands-on exercises in the Judge system, because learning coding is only possible through coding. You cannot become Java developer without writing significant amount of Java code. Let's start. Before we dive into the course, I want to show you the SoftUni Judge system, where you can get instant feedback for your exercise solutions. SoftUni Judge is an automated system for code evaluation. You just send your code for a certain coding problem and the system will tell you whether your solution is correct or not and what exactly is missing or wrong. I'm sure you will love the Judge system once you start using it. Let me show you how you can submit the solutions from your hands-on practical exercises to the automated grading system, the so-called SoftUni Judge. So you have a judging system designed to send you your code and it tells you whether the code is correct or not, and I will show you how it works. You open this link and you go on this website where is in the SoftUni Judge, and you click practice, and you have this Java full foundation course. These are the problems, and here you put your code just like it's shown here, and you submit and you send it. So for example, the first problem, student information, is this one, and this is your solution in Java, and you want to check whether your solution is correct or not. You click submit and it appears here. So you can refresh in a few moments and it tells you whether your code is correct or not. If you put some incorrect code, for example, I will format incorrectly the age and the grades of the output, and when I click here, it tells me that I have all the tests wrong, and in this case I can click the details and I can see that the expected input is like this, and my output is this one at the right. I have one additional digit which should not be there. So this is how the Judge system works. It will be your best friend when you are learning Java through our training courses, because as I repeat many times, learning Java is mostly coding and less watching videos. So you need to practice. That's why we have prepared a lot of coding exercises for you, and please do them, because I want you to become Java developers.
Hello everyone, this is George. I am your technical trainer, and today we will be talking about the Java programming language. We will see its basic syntax. We will learn about the ways we can declare variables, the way we can branch our execution of the Java code we're writing. We'll talk about how we can loop our code, meaning execute it multiple times. And we'll see other interesting things we need to know about Java before entering into the full part of its features. So most of the topics for today you should already have some idea about, but we will do a brief overview of all of them so that we're all on the same page and we can get everyone up to speed, so we can then continue on to the more specific and more difficult topics. So what are we going to talk about today? We're going to start with the introduction to the Java programming language and its basic syntax, things like declaring variables, where the entry point of your program is, and so forth. Then we'll continue on to the operators, and specifically the comparison operators, meaning how you can do operations with data inside Java with basic data types. Then we will see how we can branch our program, because every reasonable program has some branching in it. It's not just a sequence of events. It's a sequence of events that split off into different sequences of events depending on some conditions or some input. And then we'll see how we can use the logical operators to extend that branching and do more complicated checks and decide what needs to happen in different circumstances. Then we'll talk about loops, meaning how we can execute a piece of code a random number of times. And in random, I mean a number of times which is not determined while writing the code, but rather determined, for example, at execution by input from the user or by some other conditions which are generated during the program execution. And then we'll finish up by talking about debugging and troubleshooting our programs. Now, we will be doing some debugging and troubleshooting throughout the lesson, but we will focus in the last part of the lecture on the tools which the Java integrated development environment, which we will be using, called IntelliJ, offers us. So we'll see what that gives us, how we can use it, how to use it optimally, and so on. Okay, so let's get started. These are topics which you should have some understanding of, but we will cover them again, just so we're sure that everyone is on the same page. So, what do we need to know about Java? Well, Java is a modern programming language which has a huge community behind it, an international community, and a not exactly monetized community, meaning it's the specifications for Java are generated by an sort of an open committee. It's a modern language which gets updated all the time. There was a period in the early 2000s in which Java didn't really get a lot of updates, but currently it's getting updates every year or so. So it's really an up-to-speed programming language which has a lot of the features other newer programming languages have introduced. It's flexible, meaning that you can write code in different paradigms and in different ways, although the preferred way of writing code is through object-oriented programming, which we will cover further on. It's general purpose, meaning that it isn't specifically for, let's say, games, or specifically for business, or specifically for desktop applications. It's a language that can be used for pretty much everything you need, although its major usages are in business applications, in larger company software, although it does have some entries into the world of mobile development. Actually, a lot of mobile apps are implemented in Java. And it has some really neat libraries which allow it to even function as a client-side scripting language like JavaScript. So there are libraries and frameworks which allow you to write Java code which is executed inside the browser directly. Although it is actually Java code translated into JavaScript, but let's not dive into that right now. So the preferred way of writing Java is object-oriented programming. And Java is actually object-oriented by nature, meaning that everything you create in Java is a class or an object, and classes and objects are concepts which are created in programming to represent the real world. So we will be talking about that further on. But for now, what we need to really know is that Java is statically typed, meaning that once you create a variable of a certain type, for example, an integer, that variable remains an integer. It will always contain an integer inside it. It can't contain anything else, meaning that Java checks for incorrect assignments of data, meaning if you have a variable somewhere and you accidentally assign it a value which isn't of the type of that variable, you will get a compile time error, and compile time errors are good things because you don't have to debug them. The compiler just tells you what's wrong. Whereas runtime errors aren't that easy to debug because you need to execute the program again and again until you find the issue. Okay, so Java is also a compiled language, meaning that there are two steps in running a Java program. The first step is compilation, meaning that you compile, you gather up all the code you have written, and you create an executable file from that. And then, after compiling that, you run the Java program. So during compile time, you can the Java compiler can detect errors in, for example, data variable type assignment, or other stuff which will help you write your code error-free. And only then, after all of the compile time checks are done, does the program run. So in compiled languages, there are also two descriptions of time, let's say. There's compile time and runtime, meaning that compile time is when you hear that something is known compile time, it means that it is known while you're writing the code. For example, if you're executing something 10 times and it's always 10 times, it doesn't depend on user input or some calculation, that's compile time information. That's information that is always the same regardless of the execution of the program. Whereas if something is runtime, for example, user input is runtime, then you don't know that during compilation, meaning you don't know that when you're writing the code. It is something you need to handle during the execution, meaning that your code should be able to handle different situations of user input and handle them correctly. So when we're talking about compile time and runtime, that separation comes from the fact that Java is a compiled language. Okay, so how does a Java program look? Well, every Java program begins with a class, some class. It's usually going to be the class main in our examples, but further on there are going to be other classes once we cover the subject of objects and classes. And inside that class main you will have a public static void main, and this is called a method. This is the entry point of every Java program, meaning that it doesn't matter what code you have in your program will always start from here. It will compile everything else, but the execution, the runtime of your program will start from here, from the first line inside this static void main method. Okay, and here, of course, we now write our source code so we can implement Java code. Further on, we will learn how we can create other methods which accept parameters and have return types. We will see how to use them, how to call them from main, and so on. But for now, all we need to know is that every Java program starts over here. That is the first instruction executed by any Java program. Okay, so when writing Java, we will be using the latest Java development kit, which is the JDK 12 currently. However, you could even fall back to JDK 8. That's what I'm using currently. The subjects we will be covering in this course will not be needing all of the advanced features from Java 12. That's because a lot of the code which we're going to be using is fundamental computer science concepts which have been implemented in Java since a long time ago. However, we will be using some new stuff like lambdas, for example, which are available in Java 8. So you will need at least Java 8 and preferably Java 12 so you can access all of the new functionality if you decide to use it, but we won't be requiring you to use it. Okay, so what will we be using for development? We're going to be using IntelliJ IDEA. This is a powerful, very powerful development environment for Java. This is how it looks like. It's a product of JetBrains. It's one of the best editors I've ever used as a programmer, and I've used a lot of them, including a lot of Microsoft ones, a lot of open source ones. IntelliJ is pretty good at guessing what you're about to write and giving you hints on how to write it faster and saving you time doing that. So, you know, as programmers, a lot of our work is actually typing in code. Well, IntelliJ helps you type in less, meaning that it can auto-generate a lot of code you would be needing. Okay, so IntelliJ, we will be seeing it in a bit, and for using IntelliJ, you would need to create a project. So in IntelliJ, everything is bundled up inside projects. How do you create projects? Well, you open up IntelliJ, and you're going to get this screen if you haven't created any projects yet. If you already have created a project, you will probably get that project loaded in, and you can say File, New Project, which creates a new project. Now, for now, we will only be using the default Java project type, meaning that you don't need to be selecting anything over here. These are frameworks which are for more advanced application development, but for now we're going to be writing code which executes and reads input and writes output on the console, so we will not be needing any other frameworks to add into our project. So you pick your Java version here. If you've installed JDK 12, that's what you're going to get. But since I'm using JDK 8, well, my JDK version is 1.8. That's how Java numbers them. Okay, and then you click next. You don't need to use a template. We will be doing command line applications, but you don't need to be generating the command line template. We just need a simple project, and we're going to type in next here, and then we will just create our classes one by one. So once you have that created, you will just have a simple package generated over here, and then you will have a main class generated here, and this is actually what our code will look like. All of the code we're going to be writing in the first few lessons is going to be located inside this public static void main method. This is our entry point, so any code you write here will be executed. You start your program by using these icons on the top here, top right. The play icon you see is just executing your program without the debugging feature, meaning that you execute your program the way it would execute on a normal PC if you've deployed that to someone's computer, if you've deployed your program to someone's computer. My suggestion is that you use primarily the debugging mode, which is this icon over here, which allows you to place breakpoints, to inspect the data types of variables and their values, and so on. So my suggestion is use the debugging mode, although you could use the run mode if you are confident that your program is running correctly and you won't be needing to analyze any errors it might run into. Okay, so if we just run it, we will see that this program executes, and it actually does nothing. It just finished with exit code 0, which means it finished successfully. It does nothing because we haven't entered any code over here. Now we'll see how to do that in a bit, but before that, let's see what else we have to discuss from the slides. Okay, so this is how you create a new project. Oh, you could, if you want to save up generating classes, you could select the command line application template. That will generate you this main class. Otherwise, you would have to add it manually. So if you don't use the command line app template, you would need to go over here on the source folder, add a new package, name the package in some way. In this case, we just got a package automatically, which is named com.company. That's the standard way of typing packages in Java. You usually begin by your company website in reverse. So if your company is named company, you go like com.company.something. That's just a convention. It's not really necessary. Your code will still compile even if you don't write it that way, but that's sort of convention. That's how people usually do it. Okay, so from there on out, what do? Well, you click on this package over here, which you've just created, and you just say new Java class, and pick the name of that class. In our case, we automatically got a main class generated because we chose the command line program template. And then you just need to write the main method inside it, which is just this called public static void main, these parameters inside it, and the method body. Now, we will be talking about methods and what all of these public and static and void mean later on. But for now, all you need to know is that you need to have this method so your program can be run by the Java runtime, and your code comes over here. Okay, so from here on out, what do? Well, let's see how we can actually do some programming over here. Now, you probably know that programming is just creating, and it's actually processing information. It's not exactly creating information. It's just processing information from one type of information into another type of information. So one type of input into some type of output. Okay, so how do you process information? Well, you need to get that information into processable items. You need to have an item which you can process. And the items which you use in Java to process information are called variables. Variables are things which you, let's say, read from the console or initialize with some value, and then you can use to edit that value, to access that value, to print it on the console, and so on. So the typical way of initializing variables in Java is naming the data type of that variable, then telling the Java compiler what you want that piece of information to be called, meaning that you can, if you want to store integer numbers, let's say you want to calculate the sums of integer numbers or calculate how many apples you have left or something, you would create a variable called int number of apples. So what we tell the compiler here is that we want an integer data type, meaning that we will have the integer numbers inside this variable, and name the variable in some way so that we can refer to it later on. So Java knows how we call this piece of information, and then after we create this variable, we can give it a value, meaning we can place apples inside this number of apples, and let's say our apples are 6. Okay, so doing this will create a piece of information inside the computer. It will name it number of variables that will be allocated somewhere on the program stack in the RAM memory of your computer. And in that piece of memory, the value 6 in binary will be added. And you can use that value 6 from here on out with this number of apples variable. For example, you can increase it by saying number of apples plus plus, meaning increase the number of apples by 1. This would change the value of the number of apples of the memory, which is pointed by number of apples. It will change that memory address to contain the number 7. Okay, so this is how you create variables, and again, this is something you should already know by now, but we're covering it just in case. So here's an example of initializing an integer number which has the value of 5. Okay, let's actually do that in the IntelliJ IDE. By the way, IDE, whenever I say IDE, what I mean is Integrated Development Environment. What does Integrated Development Environment mean? Well, you could actually write code in just Notepad, meaning that you can start a Notepad and copy this code over here, and this would still be valid Java code. However, you would need to manually, using the command line, call the Java compiler, tell it to compile this file, first off save this file, then tell the Java compiler to find this file in your file system, compile it, and after compiling it, you would need to manually call the Java runtime to execute the compiled class file you get from your Java code file. So there's a Java code file, this is the Java code file, in this case main.java, and actually I have some other Java code files opened up here in the IntelliJ editor. For example, this is another Java code file somewhere in the Java libraries. You can guess that by the fact that it has a yellowish background. Okay, so this is a Java code file somewhere in the Java libraries, and if I want to use that Java code file, I just type in, let's say in this case, random, which is the name of the Java class and the Java code file. Random, let's call it random. Let's just import this, and IntelliJ automatically imported it, meaning that IntelliJ automatically told the compiler that it needs to go and fetch this Java code file when it's compiling my main.java Java code file. Okay, so when you're writing code like this, if you're writing in a simple notepad, it's still Java code. It can still be compiled by a Java compiler, and you can do it manually on the command line. You type in, if you've installed Java and the Java development environment, the JDK, Java Development Toolkit, you just type in Java C, as in Java compile, Java C, and then type in the path to the file, and that will generate the compiled class file from your .java file, meaning that you will get a main.class file somewhere next to your main.java file. And then on, you can use the Java runtime environment to execute that class file. And in each step of writing your code, you would need to be manually adding the features you're using from Java. Whereas if you're using an integrated development environment, the development environment does all that for you. So you don't need to think about typing in stuff manually, or compiling manually, or debugging manually, or attaching files together, and so on. So this is all handled by the integrated development environment, and all integrated development environments have such features. Okay, so this brief sideways explanation was intended to demonstrate that actually you don't need a program to write another program. You just need a way of writing text and converting that text into into operations which are executable by your machine, meaning that you need to convert it into machine language in some way, into ones and zeros. That's something that the Java IDEs do automatically for you. So that's why we're using them, but it's not obligatory to use them, although it's almost obligatory if you want to be a fast developer. Okay, so let's create some variables. Let's create our int number of apples, and we can shorten it like this. It's a fine way to shorten it. It's understandable. Num is a frequent enough usage in programming that people understand that num means number. Okay, so num apples, this creates a variable. This creates a piece of data, and we will be talking about data types later on. This creates a piece of data inside our random access memory of our computer and names it num apples, meaning that every time we access num apples in some way, for example increasing it by 1, this increases the number of apples by 1, increases this variable by 1. Every time we access it, it will access that part of memory for which this variable was allocated. Okay, now you don't need to initialize a variable immediately after creating it. You can also have this split. So you can have an integer number of apples and then followed by a semicolon, and then have the number of apples set to some value, and you can set it to values as many times as you want. Okay, so this is how you create variables, and this is how you give them value. And if you want to do that in a single step, you just say number of apples, int number of apples equals the number you want to initialize it to. Okay, so that's initialization of variables. Now if we start this program, it will still do nothing because we haven't, it will actually do something, but we won't see the result of it doing something unless we inspect memory. Okay, so let's continue on from here. Now the code I just wrote contains an integer data type. This is the type of your variable. Remember when I said that Java is a statically typed language, meaning that this number variable will always be an integer. It will never be another data type. It will never contain anything else than integers. Okay, and this is its name by which we access it in our code, and this is its value, which is the data which we write into the random access memory of our computer. So this number variable name actually isn't really seen by Java. It is only available compile time. Runtime, this number variable is just an address in memory. So the computer just sees this as an address in memory, and addresses in memories are just numbers. So your random access memory is numbered 1, 0, 1, 2, 3, and so on. And every variable you create is translated into one of these numbers later on in compilation. Okay, so once we've created our variables, let's see how we can use them actually, because I actually did use my variable. I increased it by 1, I changed its value by 1, but since we're writing console applications, there isn't really any way to view the results of our program unless we use the console input and output functions which Java provides. So Java has a built-in scanner class and other libraries which allow you to read and write to the console. Now in our case, the console will be this part of the IntelliJ integrated development environment, meaning that this over here is the console. But when you're deploying your application to actual users, which won't have IntelliJ, you will be sending them files which are executable through the Java runtime. And if they start your program from the Java runtime or from its icon, if they're using, for example, Windows, and they double click it and they have Java installed on their computer, their program will start in this command prompt or something looking like this command prompt window. So it will look like this. So your program will be executing something like this if it's running on Windows. So this is just a text input and output system which your program will access to read its input data and to print its output data. Okay. Now, how we will be deploying applications to actual users, we will cover further on. It's not something really interested in right now because we're just learning how to use the Java code. But we will learn how to read and write our input so we can see what our programs are doing. Okay, so Java has the scanner class, which allows you to write and read from the console easily, meaning that instead of writing your own code to access the console and read bytes from it and so on, you have a java.util.scanner, which if you import, you will get that Java code file compiled with your Java code file when you start the compilation process. And you use this scanner to read input from the console. Let's do that actually. So instead of having our number of apples initialized with a compile time value of 6, which will always be 6 if I don't change it to something else, instead of that, let's use a scanner. So I'll say new scanner, which initializes an object which reads from somewhere. Where does it read from? Well, I supply that as an argument to this scanner initialization. So I'm saying, scanner, please read from system.in. This is the standard input output for the system, meaning this is the console input. Usually the standard input output for a system is the console. Okay, and now once I've asked Java to create this reader, I can say, okay, once I've created it, I want to be using it. In order for me to be using it, I need a variable by which to use it. Same way as when I had a number of apples, my 6 apples when I had them, if I wanted to touch that number and change its value, I needed a variable for that number, which holds the value of that number. Well, in the same way, I would need a variable which holds the value of this scanner, so I can use it to scan. Okay, so what do I say? I say this is a scanner. I would just call it scanner because that's the name of the class. Okay, so scanner equals new scanner reading from system.in. And now instead of initializing my apples with a fixed number of 6, I can say scanner.give me the next integer from the console. Okay, so let's now increase this number of apples by 1 and now put a breakpoint over here. Now we'll be talking about debugging at the end of the lecture, but briefly, when you start your program in debugging mode, it will stop its execution on each of these breakpoints you place. You place them by simply clicking between the line number, between here and the start of your code. So you click somewhere in between. Placing a breakpoint here will cause the program to stop its execution over here and wait for you to allow it to continue its execution. Now, why would you do that? Well, because when you stop at the breakpoint, you can examine the state of your program, meaning you can examine the value of the variables which you have in your program and their values. Okay, so starting this, what are we going to get? Well, our program is now waiting for input from the console. And now we can input a number, for example, 42. And when I press enter, it will finish executing this line of code. It will get the integer from the console and write it into this variable because I said that this variable needs to be initialized with this value. Okay, and then it will stop before it increments the number of apples by 1, meaning that number of apples will be whatever I entered on the console. Okay, so if I enter 42, the program will stop here, and I can see in this variables view down to the right, I can see that I have a numapples variable and its value is 42, which I entered on the console. Okay, and if I want to continue on, I would need another line of code and another breakpoint. Let's see if we can do it like this. Now, to continue to the next breakpoint, what you do is you either press this resume program button up here to the left, or you just press F9, and this continues on to the next line of code. And since we have a it continues actually to the next breakpoint in your code. And since we have a breakpoint on the next line, well, we stopped over here, and now we can see that number of apples is actually increased to 43. And IntelliJ also lists this in line, so you can see over here I have a numapples column 43. Describing the value of apples currently, and you have the other variables too. So over here we have scanner, which is something a bit more complex, but still it's a value which IntelliJ shows you so you can view it more easily. So the variables inside the program, once you've stopped at the breakpoint, can be viewed from this variables window. And in addition to that, you can also write expressions here. So you can go over here and say insert, or press this button, okay, and say, let's say for example, num apples plus 10, and this will just calculate this sum. So this will return 53 in this case. So here it says num apples plus 10 gives the result of 53. Okay, so that's what debugging actually is. You stop your program at breakpoints and examine the values of your program at that breakpoint. Okay, continuing on from here, we had a program which read an integer from the console, assigned it to the variable numapples, and increased that numapples by 1. All things that you should have seen by now, but we're covering them so we can formalize them a bit. Okay, so you have other ways of reading input from the console. The scanner, in addition to reading integers, can read entire lines. So you can say, instead of reading apples, you can say scanner.nextLine, and this will read the so-called string variable, and let's call this variable line. So a string variable just contains a sequence of symbols. So a line from the console is a sequence of symbols. So you can enter anything you want on the console and then read it with next line, and that will give you that sequence of symbols. Okay, so if I place a breakpoint over here and start this program now in debugging mode, and I enter some line on the console, let's say hello, and I press enter, the moment I press enter, the next line operation will finish. It will get its value and set it to the line variable over here. And now if we examine the line variable, we will see that its value is hello. And again, we can examine it from here down also. Okay, so that's how you read from the console. Next line gives you strings, and you can use that string either to save, for example, a name or some other input, some other sequence of symbols input, or you can convert that input. For example, if someone enters a number, you can get the number, let's say 42, and this is a string currently because you read it with next line, and to convert it into the value of 42, notice the lack of quotes in this value over here, you use integer.parseInt, and you supply this value inside parseInt, and it returns an integer variable. Okay, so one way of reading numbers from the console is using nextInt. Another way of doing it is by using scanner.nextLine and then converting that into an integer. Let's say int number is equal to integer.parseInt, and you supply the line you just read. Or you directly say scanner.nextLine and you place it over here inside parseInt. Both would work. This is a bit more descriptive. So now if I start this program, we will see that line will contain the string 42, whereas number will contain the number 42, the integer value of 42. So I type in 42, and here I see that line is the string 42. It's just a sequence of symbols. It can't do arithmetic on it. However, number is the number 42, and we can do arithmetic on the number variable. Okay, so that's reading from the console, and of course there are things like next double, next line, or simply scanner.next, like this. This will read the next sequence of characters, which isn't separated by some of the separators. Now, what are these separators? Well, spaces, new lines, tabs, and so on. Other white space characters are separators, meaning that if I say scanner.next, then I initialize a variable string input equals scanner.next. What will happen if I place a breakpoint directly after that is if I write hello space world and I press enter, what I'll see is that input got only hello. And if I say scanner.next again, I can do that actually while I'm in a breakpoint. I can insert a watch here and say scanner.next, and this just read world. And if I edit it and press enter again, it will get the next value and then the next value and then the next value. So scanner.next reads words. You can think of it as reading words, reading by a word. Okay, so let's stop this program. We don't need it anymore for now. You can also parse lines into doubles by using double.parseDouble, or you can use scanner.nextDouble, which effectively does scanner.next and then parses it into a double through double.parse. Okay, so how do we print to the console? Well, you can use the system.out libraries or system.out collection of methods, and there are various ways of printing to the console. System.out.print just prints whatever you give it. So if you add a number, it will print a number. If you supply a string like this one, it will print a string, and so on. Print line will print the same way as print does, however it will add a new line character at the end. It will just move the cursor on the next line after printing whatever you supplied to it. Okay, so the more interesting usage of printing is formatting. So you can do system.out.printf, F short for format, print with a format, and then you supply the format string, meaning how you want the values you're printing to be displayed. And in this case, we want to have the string name followed by a space, followed by some string. Which is the string? Well, the first string after the format which we described. So this over here is the format. The first variable, the first thing we supply to printf is the format. And then it starts accessing the variables after it. So over here we have this format which contains the string name and contains the digits described by age over here. So this is what printf does. It just prints formatted output. So if we wanted to say enter a number and write on the console, let's read a line with the scanner, read a number from a single line on the console, parse it into an integer, save it into the variable number, and then I want to print out system.out.printf you just entered column, and I want to print my number over here. How do I do that? Well, I need to tell Java where I need this number to appear in this format. Well, I need it to appear at the end of the format. So if I start this program and input a number, I will have this message printed. You just entered and the number I entered. So if I enter 42, I got you just entered 42. Now notice that from here on out we don't have a new line. Why don't we have a new line? Well, because printf doesn't print a new line. If you wanted to print a new line, you say %n, which means print a new line over here. So if I start this over like this, I actually just click the start with code coverage, which will do some stuff I don't really need to. Starting with code coverage just analyzes which parts of your program are executed. We don't need that right now, so let's start the normal debugging mode. So if I enter 42, now I got you just entered 42, and the other messages on the console which I get due to the debugging mode are printed on the next line. And that's thanks to this %n I added at the end of the format string. Okay, so this is how we print formatted output. So printing with the symbol D prints digits, integer digits, and you can pad that with a certain amount of leading digits if you want. And if you add F, that prints a floating point number. So D is for digits of an integer number, whereas F is digits of a floating point number, meaning a number like 5.3, let's say. Okay, so if you want to print with the string %03D, that means write the number I supplied to you, but pad that with zeros so that it has at least 3 symbols in it, meaning that in this case we got 055 instead of just 55 on the console. And for printing floating point numbers, you have the .2, meaning write this number with 2 digits after the dot of the floating point number. These are just specific formatting strings, and then you don't need to really remember them. You just need to know how to look for them. How do you look for them? You type in Google Java format strings or Java format floating point. into string, or Java format floating point string, and that will give you a lot of results on how you can print in various ways. Okay, now string.format does the exact same thing as system.out.printf. However, it doesn't print to the console directly, it just generates a sequence of symbols, it just generates a string. So exact same mode of operation like system.out.println, exact same way of supplying parameters. However, it doesn't really print to the console, it just creates a string, which you can then print to the console or use for something else. The use of string.format is to create a string which you can use for other purposes, for example, to connect it with other strings. Okay, so we have a task here and we'll do it briefly. We will have 3 input lines entered, a student name, an age, and an average grade, and we need to print it in this format. Okay, and we want the grade to be printed to 2 decimal places, meaning that we would need what? %.2f. So we're printing a floating point value, and we want that floating point value to be printed with 2 digits after the decimal point. Okay, so how do we do that? Well, we already have our scanner, and what we need to enter is what? The student name, their age, and their average grade, and each of these will be on a separate line like so. Okay, so let's say that the string name is equal to scanner.nextLine, and the age is equal to scanner.next. We could use nextInt, but let's use nextLine because we're informed that it's going to be an entire line containing just that number. So let's read that entire line and convert that into a number using integer.parseInt. And the last thing we need to enter is the grade, meaning that we need to enter double grade, which is equal to double.parse a double from the next line after that. Okay, and how do we print that out? Well, let's use that string.format function and then print the string we just got. So we will do string.format, and here we will have the input string, and I'll just copy this I got here, and then I'll convert it into a Java format string. So I'll paste this, I'll provide the parameters, the name, the age, and the grade we want printed, and now I'll just change whatever I need so I can get the correct output. Okay, so instead of name, how would we print a string? Well, %s. How do we print digits of an integer number? We say %d. And how do we print the grade? By the way, I'd guess that there's a missed colon here. So the grade, and what do we have here? We have %f for printing a floating point number, but in order to print that to 2 decimal places, we need to say decimal places 2. Okay, so running this program will just allow us to input information like the one we have here, and I will actually copy that and paste it into the console over here. And what did I get? I didn't get anything. Why didn't I get anything? Well, because I just formatted a string, but that doesn't print to the console, that generates a new string. So this is a piece of information I'm not using. Why am I not using it? Well, because it's not sent into a variable. I need to send it into a variable and then send that variable to the console, or directly send this result to the console. Meaning that here we just generated a result, but we're not using it. Okay, so let's use it. String output equals string.format this, and then system.out.print a line. Let's print a line with this output. Okay, so print this output on the console, and now we're using this value. So we have a value somewhere in memory, and we're telling the Java runtime that we're going to be addressing this value through this variable. So when we talk about this variable, we're talking about this value. Okay, and now we're just saying print this value on the console. So if I start this code again, and if I copy the input again and paste it into the Java console, when I press enter, I'm going to get name John, age 15, and grade 5.40. Is that correct according to the input over here? Yes, it seems correct. Okay, so continuing on, we can test this program a lot more, of course, but let's not play around with it right now. We have other stuff to cover, and here we have a solution which is pretty much similar to what we already did. However, in this case, it's printf instead of string.format and then print. Okay, so Another thing we need to discuss are comparison operators in Java. So what we had up until now was just reading variables. If we want to do something with these variables, we use operators. So we use operators which operate on the data which we have. Operators are just parts of Java syntax which execute actions on some data we have. Now, comparison operators in specific are things which can compare values inside our Java code. Now, of course, we have the normal operators which are adding numbers, subtracting numbers. So if you say int sum equals 4 plus 3, well, this is an operator. It's an arithmetic operator which sums two numbers which are to the two sides of that plus operator. So these operators, the arithmetic operators, are the same ones you're used to from mathematics class. So they're nothing special. Well, what are comparison operators? Well, comparison operators are a way to examine values against other values in Java. So what you have is equality checks, inequality checks, greater than or equal, less than, and less than or equal. So the mathematical operations basically, however, the way we write them is a bit different. So if you want to check for equality, you use double equals sign instead of single equals sign. Why? Well, because the single equals sign just changes the value. So this single equals sign means change the value of the memory which is pointed to by this name variable. Whereas the double equals sign checks whether two things are equal, and that returns either a true result, meaning that two values are either equal or they are not equal. So there are only two possible answers to the question A equals B. So this is just a check, and the result of this check, since it's only two possible values, is a Boolean result. So R equals A equals B. So this might seem a bit confusing at first. So what we're saying here is you just need to know that you shouldn't be reading this as equals. It is a sign. You use this equal sign here as the word assign. So what we're saying is R equal, this piece of information, gets assigned with the value of does A equal B, and this is either true or it's false. And in this example, it's what? It's false, right? Because 5 isn't equal to 10. So the R equal variable will contain the value false. Okay, so you can save that into a Boolean variable and then print it out, for example, or use it in a conditional statement. We will see that further on. Or you can just print it on the console. So if you say is A less than B, then you get the result true for these two variables. And here we have other examples. You can play around with these ones at home if you want, and you can check other values. But again, this is something you should already know by now. So we're just formalizing this information and gathering it up in a neat little place where you can go and check later on, because what programmers do isn't remember. What programmers do is remember how to search. So programmers are good at searching for information, not at remembering for information. So that's why we have an entire lecture which has this information summed up, so you can find it easily if you need to. Okay, so we've reached the conditional statements, which will give us the answer to why do we need to compare numbers, why do we need these comparison operators. We saw what conditional operators are. Now let's see how we can use them in if-else statements. Now what is the if-else statement? It's something which you see in this picture. So an if-else statement, a conditional operator, a conditional operation, a branching operation in programming, is where you check for some condition, for some comparison, for let's say between two variables, and then you output you execute either one piece of your program or another piece of your program, or you just do nothing. So this is what the if-else statement does. This is the way you can branch your program. Now, typically, programs don't just read input, do calculations on that input, and write output. That's not a program, that's a calculator. You know, that's what calculators do. Now, computers can be calculators, but they can also be much more than calculators. They can do different things based on different input, meaning that they can handle different input differently. Okay, so what does the if statement do? It tests for some condition. Now, like we had over here, we entered a name, an age, and a grade for a student, and all of these are potential targets for an if statement where we can check something about those variables. Now, let's simplify these examples a bit, and let's just see how the if statement works. So the if statement is just the if keyword followed by these curved brackets and then followed by these curly brackets. And inside that if statement, you place the condition which you want to check. So if you want to check something, for example, let's say you have two numbers, the number A, which is, let's say, 5, and the number B, which is, let's say, 10, like we had in the slides a bit back. If you say if A less than B, then system.out.print B is larger. What will happen if we execute this code? We will see that the output B is larger is printed on the console. Okay, so now we have that on the console. Now, if the values were different, if the values were reversed, let's say, what would happen is that this code will not be executed. So we have a branch of code over here. We have our program running and doing sequences of operations, and then it does a check. And if that check is true, it executes some other code, and then it returns to wherever it was. So returns after it executes that code. Now, this is just an if check. So this code will only be executed if A is less than B, which is always true in our case, since that's what we create as variables. That's why, by the way, IntelliJ marks this code in a deeper yellow, indicating that this value is always false. So IntelliJ warns you about stuff like this, where you might not be doing what you're thinking you're doing. Now, if these were numbers that are read from the scanner, next int, and B is also equal to scanner.nextInt. If these two are numbers read from the scanner, read from the console, this warning highlight disappeared, because now this isn't something that's always going to be true. In this case, it might be anything. That's actually the use of conditional statements. You check for conditions which are usually determined by the input in some way. So the user, for example, in our case, enters two numbers, and we check which of them is larger. Now, if this isn't true, the rest of the code will just execute. So if we say system.out.print line program exiting, this code will be executed. So whether or not A was less than B, this code will execute normally, just like it would have if the if condition didn't exist over here. So now if we want to, let's say, read two numbers and then print in one case one output and another output. So in this case, if we say 5 and 10, like we had initially, we're going to get B is larger, and now I noticed that we missed the new line symbol in this output. So we're going to get B is larger in this case. However, if we input them in another way, let's say 10 and 5, we're not going to get anything. We're just going to get program exiting. Now, if we want to print A is larger, if A is the larger value, well, that's the case in the else statement, in the else branch. So the else branch gets executed only if the if branch didn't execute. So if you say if, and this expression over here is false, then the else branch will execute without the if branch executing. Okay, so now what would we want to print here? Well, we want to print A is larger than B or equal to B. Why do we say that? Well, because if A isn't smaller than B, so if this is false, then A is either equal to B, because this would be false if A is equal to B, or A is larger than B. So we can't just say A is larger, because if they are equal, well, they are equal. So executing it like this, what we'd get is, if I enter 10 and 5, I'd get A is larger than B or equal to B. So only this part of the code executed. Now, one thing you can do with if-else statements is if you're going only to have one line of code in them, one statement, not exactly one line of code, but one statement, one thing that gets executed, one piece of code followed by a single semicolon. That's a neat way of figuring it out if it's one thing or more than one thing. Each statement in Java ends with a semicolon. So if you only have one semicolon, that's only one thing. Okay, so in this case, you can remove these brackets. So you can say if no brackets, else no brackets, because both of these do just one thing. If they do just one thing, it's okay for you to use no brackets. Now, my suggestion is don't do this. It's really easy to make a mistake if you don't always add your bodies. These are called the bodies of the conditional statement in this case, but it can also be the body of a loop or the body of a method like we have here in main, and so on. So always add these, because it's very easy to make a mistake. It's very easy to add another statement over here and think this other statement is part of this else, but it actually isn't. It's a part of code which will always execute if you add it like this. So always place the brackets so you are absolutely certain which parts of the code are executed when. Now, that actually gives us a neat way of chaining if and else method, if and else checks. Now, before we see that, let's try to separate this into a more specific output. So let's say that if A is less than B, then if A isn't less than B, then we want to print precisely whether A is larger than B or whether A is equal to B. So in our current situation, we print one or the other, but we want to be specific. We want to be concise, whether it's equal or it's larger. Okay, so how do we check that? Well, if A isn't less than B, then there are checks we can do. What check can we do? Well, we can check if A equals B inside this else. So we only enter this part of the code if A is not less than B. So this code will only execute then. And then I say, if A is equal to B, then execute this code. Which is this code? Well, this code is going to be system.out.println, and this line is going to be A is equal to B. That's what I'm printing. And if it isn't equal to B, what's left? Well, what's left is that A should be larger than B, because we know that if we got to this part of the code, then A wasn't less than B. And if we got to the else over here, so if we got to this part of the code, then A wasn't equal to B. Well, the only other option is for A to be larger than B. Okay, so you can place if-elses inside other if-elses in any way you like. This is just a part of code that executes. When the code reaches here, it doesn't really care whether it's in an if or an else or whatever. It doesn't know, it just executes. So you can nest these all you want. Now, a more optimal way of writing this, so it takes up less space and is a bit easier to read, is, what did I say about not having to add these brackets when there's only one thing over here? Is there only one thing over here? Well, yes, this is only one thing. It might seem like two things, but it's part of the same if-else statement, so this thing goes together. Yes, there is code inside it, but the whole piece doesn't have any semicolons after it. Now, if there was another statement over here, then it wouldn't be a single thing. But there isn't. There is only a single statement over here. So this else only contains a single statement. And I can remove the braces from this if statement, and even IntelliJ allows me to do that automatically by pressing Alt and Enter over here. And if I do that, look what I got. I got an else if. There's actually no such thing as else if like a keyword. It's not a separate keyword. It's just a sequence of an if followed an else followed directly by an if, which has its own else. So this code is absolutely identical to this code. So what am I doing here? I'm saying if A is less than B, then print whatever message I want to print. Otherwise, if A is equal to B, so otherwise if this wasn't true, but if this is true over here, then print that they are equal. And if this thing isn't true, what's connected to this not being true? Well, this else over here. So we're chaining them. You can think of it as a chain. You check this, and then you check this, and if nothing matches, you go to the last else. Okay, and how it gets structured in code, I just showed you by typing them out before I removed the braces. Okay, so if I start this program, it will now list whether A is larger, equal, or less than B. Okay, so if I enter 10, what I'm going to get, am I going to get something? Well, I'm not going to get anything because I haven't entered the other number. Then I'll enter 10 again, and what did I get? I got A is equal to B, so I got this part. And if A gets larger than B, if I say 10 and 9, then I'll get A is larger than B. Okay, so this is what conditional statements look like. So here's another example. We're reading something from the console, and we're checking whether it's larger than a certain number. And if it is, then we print something out. Otherwise, if we want to do something else, we can use an else condition. If we want to react to the statement not being true, this check not being true, we add an else statement. In some cases, we want an else statement. In other cases, we don't. So in some cases, we only want to execute a piece of code if some condition matches. And if that condition doesn't match, we just don't execute that part of the code. In that case, we just use an if. If we want to execute one piece of a code if the condition matches, but another piece of the code if the condition doesn't match, well, then we need an else. Okay, so this was the example for passing a grade. Let's see what we have here as a task, as a programming problem. So we have an hour entered, a time entered as an hour and an amount of minutes, so hours and minutes. And what I need to print is 30 minutes after that hour. Now there are a lot of ways to do that, but let's do that with if-else, since that's what we're learning right now. So we're doing that with if-else. How are we doing that? Well, what's going to happen? Let's solve it in the simplest way possible. So when you're trying to solve a programming problem, you don't need to think of the entire solution at once. You just need to think of the parts of the solution and then wire them together. So I'm still going to have two numbers. The first number is going to be the hours, and the second number is going to be the minutes. Okay, and what am I supposed to do? Well, I'm supposed to calculate 30 minutes from here on out. So if I get the 0 hours, 1 minutes, I need to print out 0 followed by 31, 30 minutes after this time. Okay, how do I do that? Well, I just increase the minutes, right? So I say minutes equals minutes plus 60, right? Okay, well, not 60, but 30. We wanted 30. Okay, and I would print this. Again, this is not the complete solution. It's not accurate yet, but it doesn't need to be. Let's implement a sort of working solution which can read the input and write the output, and then we'll figure out how to fix it. Okay, so system.out.printf. Why am I using printf? Well, because I'm going to be formatting a string. I'm going to be printing the hours and the minutes, and I also need the minutes to be padded with zeros if there aren't enough digits in them. Okay, so how would I write this format? Well, I have an integer over here, the digits of an integer, followed by a column, and then followed by the digits of another integer. But I want these digits of the second integer to always be at least 2 and padded by zeros. Okay, and now what do I need? Well, I need that integer, those integers. So the first integer is hours, the second integer is minutes. Okay, so let's see if this program works correctly. It won't work absolutely correctly, but it will get some of the job done. So let's enter some input. Let's say 0 and 0, 1, like we had in the second example. Okay, so we printed 0 column 31, and I don't have a new line over here, so let's add that, %n. Okay, so we know that part works correctly, but what part doesn't work correctly? Well, if I overstep the minutes, so if the minutes get more than 60, so if the sum over here gets more than 60, if I enter 159, for example, or even 131, or even 130. If I enter 130, 30 plus 30, actually the input is like this. If I enter 130, well, 30 plus 30 is 60. So if I press enter here, I get 1 and then 60, but there's no such thing as 60 minutes past 1. There's 59 minutes past 1, and then 60 minutes past 1 is 2 o'clock, right? 2 with zeros after it. So how do I calculate that correctly? Well, what would I do? I would need to check something. You know, if my minutes change in such a way, normally I just sum them up. But in some cases, they will, in half the cases actually, because in any case after 30, from 31 to 59 inclusively, what would happen is that I'd need to change not just the minutes but the hours. So when the minutes change above or if they become above or equal to 60, then I'd need to change the hours and to reduce the minutes by what? Well, in this example, with 160 would become 200. Okay, so what happened? Well, I increased the hours by 1 and I reduced the minutes by 60. Okay, so let's do that. Now, when do I need that? Only when the minutes are larger than or equal to 60. Okay, so if the minutes are larger than or equal to 60, I say minutes equals minutes minus 60, or I can shorten that into minutes minus equals 60, the same way I can shorten this one to minutes plus equals 30. Okay, and what else do I need to do? Well, I need to bump the hours. Okay, so hours plus plus. Okay, anything else? Let's test if this code works correctly. We started, we wait a bit for it to execute, and I enter 1:30, and I get 2 o'clock. By the way, ignore this error over here. This is just an error coming from the debugging software in IntelliJ, or the debugging environment in Java. It doesn't really matter. All you care about is this green input and this black output. You have all the other messages you can ignore. Okay, so 2 o'clock, that's correct. Okay, is there a case in which this code won't work? Well, look at what I'm bumping. Like, when I'm bumping the minutes, there is a case in which I need to also bump the hours. Now, if I'm bumping the hours, I'm changing something else in my in the state of my program. So I'm changing the hours. Is there a situation in which when I change the hours, they aren't a valid number for time representation? Well, there is. If it was 23:30, so if I start this program and enter 23:30, what do I get? 24 o'clock. But there isn't such thing as 24, because the time begins from 0 hours 0 minutes and ends with 23 hours 59 minutes. So 24:00, that thing doesn't exist. We've gone to the next day, so 24:00 is actually what? 0000, right? So what I need to do is, after I've changed the hours, after this code has executed, if it has executed, I don't really care if it has executed, I just need to check, okay, so the hours here have changed, and now I can add another if statement. This if statement is unrelated to this if statement. It's just another check coming after it, which is if hours are larger than 23, or if hours are larger than or equal to 24, then what do I need to do? Well, I need to reduce the hours by 24, the same way I reduced the minutes by 60. Now, in our task, I can just set them to 0, so I can just say hours equals 0, because I'm only adding 30 minutes. But if I want to be adding not just 30 minutes, but any number of minutes, well, then I'd probably need to subtract 24 from the hours, because we could jump up with more hours than a single hour. Okay, so it could become more than, let's say, 30 minutes past midnight. Okay, but in this case, it's completely sufficient to just know the hours, because I know that I can't get to 1 o'clock in the morning by just adding 30 minutes from the previous day. It's not possible arithmetically. Okay, so let's test this situation. Waiting a bit. 23, 30, and I got 0, 0. Okay, so seems like my program works correctly, and of course I should test with all of these sample inputs and try to think of my own sample inputs so I can test out my program sufficiently. But since we're in a lecture here, we won't be wasting that time for that too much. So the checks over here are pretty much the same which we had in our program, and the logic is pretty much the same. Okay, now in addition to branching using the conditional statement if, you can also do branching with the switch case statement. Now the switch case statement is usually applied to situations where you have a fixed number of values which you want to handle in a fixed number of ways. And you can easily count these values, and each of these values has a distinct way of being handled. Now what do I mean by that? Well, let's say we have a task where we get a day of the week entered from the console, like 1, 2, 3, 4, 5, 6, 7, and we should print the name of that day of the week. How would I do that? Well, using just branching the conditional statement if, what I do would be if day of week equals 1, then I'd print on the console system.out.print line, print on the console a single line containing Monday. And now if it isn't Monday, then it's going to be something else. What else could it be? Well, it could be Tuesday. So if day of week isn't 1 but it's 2, then system.out.print line Tuesday. And so on and so forth for all the values of the week. And after all the checks, I would have an ending else, so I would have other checks over here. So there would be other if day of week equals 3, if day of week equals 4, if day of week equals 5, and so on. I won't be writing all of these down. But at the end, I'd probably have system.out.print line unknown. Because if someone enters 8 or 9 or -1, well, what should I print? I don't know. I don't know what day that is. So I should inform the user in some way that their input wasn't correct. Or maybe I should say incorrect number, please enter a number between 1 and 7. Okay, so this is a way to solve that task, but it's a bit of a hassle. Why? Well, because I'm doing a lot of if-elsing. Now, since we're checking against specific values, exact specific values, what I can do instead is say switch, use this day of week as a switch, which has positions. That's where switch comes from. So this is my switch. My day of week is my switch, like a switch in a control room, a switch for something. Okay, and in the case in which the switch is in position 1, meaning day of week equals 1, then do the following and then break. Now this break is very important and I'll explain it in a bit. Okay, so case 1, break. So if day of week is equal to 1, do some stuff over here. I'll implement it in a bit, and then stop, meaning exit this switch case statement. Okay, so break out of this switch, exit this switch. Okay, so the cases over here say that if this value equals this case, then start executing the code from here downwards. Okay, so what do I need to execute? Well, I'd execute system.out.println Monday. And then the other case would be for value 2, system.out.println Tuesday. And so on. And my final else, which is the unknown case, is handled by the default case. So anything other than the cases I mentioned here will enter this code. By the way, I forgot the break here, and I'll explain why I really need this break over here. So the default case would be system.out.println unknown, and another break again. Okay, so this effectively replaces the if-elses I had downward. Okay, so the if-elses I wrote previously are completely replaced by this switch case. Okay, so starting this code, what I'd get is if I input 1, I'd get Monday, if I input 2, I'd get Tuesday, and if I input anything else, I'd get unknown. Of course, there are other cases to be added here, but I won't be adding them now so we don't waste time on that. I think you understand the concept up until this point. Okay, so that's what switch case does. It just checks values of a variable against specific cases and executes the code following that label of the case. Now, why do I say that you always need to add break? Well, because if you don't add break like this, what happens is the code continues to execute. So let's say I remove this break over here. Instead of printing just Monday, this code will also print Tuesday. Why? Because that's how switch case works. Switch case just enters over here and starts executing code from here on out. It doesn't care about the other cases. So the cases are actually just markers which say start from here. Let's see this in action. So if I enter 1, instead of just Monday, I get both Monday and Tuesday. Why? Because Java saw that case 1 starts here and it just started executing code from here on out. It doesn't do any more checks. And the break I add, the break I want added here, is a signal to Java to get out of this switch and continue after it. So that's what break does. Now, in some cases, you do want to continue executing downwards, but in most cases you don't. So the way I suggest you write switch case statements is always case, then the case you want, and then immediately break, and then you can start creating the code you want to have handle that case. So always the case, then the dots, then the break, and then in between you add the code. Now in some cases, again, you would want to fall through to the other case, like we just demonstrated without this break. In some cases you would actually want that behavior, but in most cases you won't. So let's ignore that for now. Okay, so this is the switch case statement, and what it does is just handle a specific value of a specific variable. It's just an equality check. You can't use it for range checks. For example, if you're testing whether a person is less than 18 years old, you would need an if statement for that, or you would need to write 18 cases in a switch, which isn't really practical, and that's for a relatively small number. Let's say if you're checking a person whether they are 65 and older for some program which calculates something about coupons for, let's say, people which are in retirement, for example. Well, in that case, you can't really do that with the switch case, because there are a lot of switches and a lot of cases you need to write, which you need to handle. Whereas, so if-else statements are used when you have range checks and other more complicated checks. Switch case statements are only used when you have very specific cases which you need to handle, like these months of the year we have over here. Okay, so we have a problem, which is if we're given a country, we need to, well, if we're given a language, we need to print the following countries for that language. Okay, so for English, we need to print England and USA, and for Spanish, we need to print Spain, Argentina, and Mexico, and for others, we don't know. So if we get England, we should get English. If we get Spain, we should get Spanish. So this is a bit, the description is a bit in reverse of what the input actually is. So we get England and we print English, and we get USA and we print English again. Remember when I said that switch case has some situations where you actually do want to not have a break? Well, this is exactly one of these situations, because for two different cases we will be executing the same code. Okay, so let's do that. We're getting a language, we're getting a country. Since we're getting a country, we're getting, this is what? A string variable, a sequence of symbols. So here's a string country, which we're reading from the console. So country is equal to scanner, give me the next line from the console. Okay, and I'm switching my country now, and the switch for my country will be, if the country is England, then I'll do one thing. I'll figure out what that thing will be later on. I'll write out all my cases, and then I'll see how I can handle them, and I'll write them with breaks. Why am I writing them with breaks? Well, because I don't know how exactly I'm going to be handling it, and I already said that when I'm writing a switch case, until I figure everything out, I just place breaks everywhere. Okay, so what are the other countries? USA, then Spain, Argentina, and Mexico. Okay, so this thing, we get it copied, we paste it, we say Spain, then we say Argentina, and then we say Mexico. Okay, and do we have a default case? Well, if we get something else, we get unknown. So we should probably print unknown or something. Okay, so we can check that output, what it should exactly be, and in a well-described task it would be a bit more specifically stated, but let's print unknown like we have here. Only they had it with lowercase letters. Okay, so now what do we do? Well, we start printing. So for England, we'd do system.out.println English. But for USA, we do the same, right? So we do the exact same code. Now, since switch case can just continue on downwards, we can do this. Instead of breaking on England, we can just say, if the country is England, start executing code from here. And that will come over here, execute the print, and break then. Okay? And then if we get USA, it will still start from here and break then. So in both cases, we will actually execute the same code. And for Spain, Argentina, and Mexico, it's the same deal. So if it's Spain or Argentina or Mexico, then system.out.print of what's the language? Spanish. Okay, so that's the solution of this task. Now, one thing I still don't like about this program and about the one we had for the days of the week is that I'm repeating code. Where am I repeating that code? Well, I'm repeating system.out.println. So here and here and here, I'm doing a repetition of code. The only thing that changes is the string I'm printing. So whenever, as a programmer, you see something repeating, and if the repeating thing is a value, if a value repeats, what you need to do is extract a variable. So let's create a variable language, and now we'll just say, instead of printing it, we'll say that language equals English in this case. Otherwise, language equals Spanish, and otherwise, language equals unknown. And then I'll have a single print after the switch case. So here is the beginning of the switch case, here is the end of the switch case, and now I'll have a single system.out.println and supply that language as a parameter. Okay, so now I eliminated the repetition of the system.out.println code, and it could have been longer code. This is just an example. It's not like this was a really big issue of repeating code, but the concept applies. If you see that a piece of code is the same and it only has its value change, well, extract that value into a variable and then add the piece of code after the different values of the variable are determined. Okay, so now if I type in USA, I should get English, and that's what I got. Of course, I should test out this program a lot more, and I suggest you do that at home, but for now we're going to continue on with the lecture. Okay, so this is pretty much what we have in the slides for the solution for this problem. Okay, now we've already seen the logical operators, the comparison operators, and we've seen how they can be used in if statements, in conditional statements. what we need to add to that are the logical operators. The logical operators are what allows us to combine true and false values into a single expression. So let's say that we had, let's say we have the following situation. We're going not to be reading countries from the input. We're going to be reading the age of someone and their money. What am I implementing? I'm implementing a bar. So we're going to be having a bar, and in this bar only people which have enough money and which are of legal age can buy a drink. It seems logical. Okay, so what I'm reading from the console is I'll read an integer, which is the money of the person. We'll not go into specifics of whether this is cents or something. We'll just have a hard limit on the price of the drinks. And this is the age of the person, scanner.nextInt. And what is my task? My task is to determine whether this person can buy a drink which has a price of, let's say, 50. 50, we don't say what. Let's just say 50. Okay, $50, for example. Okay, so the price of my drink is 50. And the age needs to be larger than or equal to 18 for the person to be able to buy a drink. So if I don't have the logical operators, how would I do that? Well, I'd say if money is larger than or equal to 50, if the person has enough money, and then if the person has enough age, let's say, if they are legal age, then I'll print system.out.print can buy. Now, if they aren't at least 18, I need to print that they can't buy. So this is going to be, let's say, get out. Let's say we're forcing this person to leave. Okay. And if their money isn't enough, we're also printing get out. So this is a solution to this task without using the logical operators. But as you see, first off, we're repeating code over here. In both cases, we're printing get out. And this code is using nested ifs just so it can check a sequence of things. And it does the same thing if one of the checks fails. So if one of these checks fails, it prints gets out. And in both cases, it basically prints gets out if one of the checks fail. So it's actually a single expression, right? Both of these need to be true in order for the program to print can buy. Otherwise, it will print get out. So this is a single expression. It acts like a single expression in our program. So what we have for handling such situations is, instead of writing a separate branching, so we can check each of these, and imagine if there are 3 variables or 4 variables we need to check, it would get even harder to read and to code. So what we have instead are logical operators. Logical operators combine Boolean expressions like this one, combine checks like this one into single expressions. So if I want to say that their money needs to be larger than 50 and at the same time their age needs to be larger than 18, this is how I do it. Now the AND operator requires both of these to be true in order for the entire thing to be true. So if one of these is false, the entire thing will be false, regardless of the value of the other thing. Okay, and by the way, if the AND operator works like this, if it sees that this is false, it's not going to execute this part. It doesn't care. If the first part isn't true, it doesn't need to evaluate the second part. It doesn't need to waste time evaluating the second part, because the entire expression will be false regardless of this value over here, if the first part is false. So this is called short-circuiting. Once it knows a result, it doesn't care from there on out. Now, if this is true, if this part is true, then it needs to check the next part, because that one could be false. Okay, so this is how we solve that task with the and the logical operator and there's also a logical operator or. That one is the less restrictive one. So that says if either of these is true, the result is true. Whereas for and, it's if both of them are true, then the result is true. So if both of them are true, the result is true. Otherwise, the result is false. Here, the only way for the result to be false is if both are false. So the logical or is sort of like a reverse of the logical and, a reverse in concept. And in what cases do we need to use that? Well, let's say we want to check if the person has money, or they are of the correct age, and they're of the correct age, or if they aren't of the correct age, they may be getting, they may have a person with them. So someone which is of the correct age, which can buy them the drink or something like that. So if there's another person. So in cases in which if either condition suffice, that's when we use the or statement. Okay, and in addition to that, there's also the logical not statement, which just reverses a value. So if a value is true, it reverses it to false. Okay, so we have a task over here, which requires us to check theater promotions. Well, how do they work? How do these promotions work? Well, if the day is a weekday, we use this part of the table. If it's a weekend, we use this part of the table. And if it's a holiday, we use this part of the table. So what does it look like? This over here is what? These are 3 fixed values, exactly 3 fixed values. And in each of them, we have different handling for different ages. So we have a weekday, we have a day, or whatever we call that. We have a day, and we have an age, which are entered. Okay, so for one weekday, for one day value, we have the check of whether the age is larger than 0 or less than 18. And then we have the check for between 18 and 84 and 64, and then we have the check for between 64 and 122. Okay, so how does this look like? Well, to me it looks like a switch case, in which the first case would be weekday, and then in that switch case I check the age for being in one of these ranges, and since I'm having ranges, what will I be using for the check? Well, I'd be using a conditional statement. Okay, and in each of the checks I just determine the value of the price of the ticket. Okay, how do I do that? So let's say we have the string for the day entered. So we have a string day, which is scanner dot next line, read the next line, and then the age is scanner dot next int. And what do I need to do? Well, I need to switch on the day. So this day is going to be in my switch, and I'd say if it's, by the way, it's not exactly clear whether these are capital case or lowercase or capital case or whatever they are. One way to check without caring for lowercase or capital case and so on is just switch the day, but not exactly the day, but the day dot to lowercase, which will convert this day to lowercase symbols, and then each of my switches will just be a case lowercase, in this case weekday with lowercase. Okay, and then I add the break here, and then I have a case for weekend, and then I have a break again, and then I can have a case for holiday, and then I have a break again, and I probably have a default value which prints, for example, no such result. Okay, so what do I do for these? And I forgot the break over here. So what would I do here? Well, if it's a weekday, now I just need to check the age. If the age is between 0 and 18, then I need to say that the price is $12. Then I need to say, well, if it's larger than 18, then the price is $18, and so on. Okay, so how would I do that? Well, that's simply a sequence of if statements. If the age is larger than or equal to 0, and now there are two checks. The age is larger than or equal to 0, and it also needs to be less than or equal to 18. So it needs to, we can't just check if it's larger than 0, we need to also check if it's less than or equal to 18. So how do I do that? Well, how do I combine checks in Java? Well, I use the AND operator if I want both of them to be true. So, and if age is less than or equal to 18. So this would give me a price of $18, right? That actually $12, sorry. That's what I have in the table. And the next check will be else if the above isn't true, if the age isn't within that range, but it is within the range of age being larger than 18. By the way, why am I adding this since the age is definitely not in this range? Well, I'm adding it because someone could have entered -1 and that won't get into this check. Okay, so if the age is larger than 18 and the age is less than or equal to 64, then I'd be printing out the $18 tax. And so on. I do the last else for if age is larger than 64 and age is less than 122. Okay, and then I'd be writing some code for the $12 tax again. Where are my dollars? Here are they. Okay, here they are actually. Here are my dollars. Okay, so of course this isn't the actual code. This would be printing to the console or setting a value to a variable, which I'd prefer, and then printing that value on the console over here. Okay, and we need to do the same for the weekend and we need to do the same for the holiday. I'll leave that to you to do at home. So I'd expect you to handle this. Oh, and here we have what happens if there's a negative value. So we need to print error. So there's going to be a last else over here, right? So in this else, there's the case error. So in this case, we need to print error like this. So what I do is create a string variable, which is string ticket price info or something. I will intentionally not give it a value, and I'll give it a value in each of these places. So in this case, it will be ticket price info equals $12 as a string. And I do that the same for 18, and I do that for error too. And now, if I go over here and print it, system.out.println, and provide ticket price info, notice that it underlines it as an error. Why does it underline it as an error? Because it might have not been initialized. Why might it not have been initialized? Well, because I'm not initializing it here, 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 and in each of these cases, I'm not initializing it. So in this way, you're ensuring that there's always a value for ticket price info. So in this way, you're ensuring you're not missing a case, basically, because everywhere you need to set a value to ticket price info, otherwise your code won't compile. And that's how you know that you've met every condition correctly. Otherwise, if you miss it somewhere, for example, we miss it here, well, this will be a compile time error. You won't need to start your program to find out that it doesn't work. The program will check for itself and see, okay, you haven't given a value to this and I can't print it. And you will just find where you haven't given a value to it and fix that. Okay, so I'm leaving this to you to finish up. They're just the same checks done over and over again. Okay, so this is the code for the solution. You can check with it if you don't manage to solve it. By the way, this code is different than what I just wrote. It's if-else checks, so that's fine too. But since we have fixed values, I'd use the switch case. So play around with one of these two solutions and write them yourself. By the way, any task we encounter here, you really should solve by yourself. It's really important, even if you've seen the solution, to write it by yourself and try to not look at the solution while you're writing it. The only way you become a good programmer is by programming. There is no shortcut. There is no way you can just listen and learn. It's just writing code. You just need to write a lot of code until it becomes so intuitive that you don't really need to think about the more simple concepts like how do I write a conditional statement or how do I write a loop, which we'll be talking about in a few moments. So really do the tasks which you see in the lectures and do them by yourself. Now, if you can't manage it by yourself the first time, help yourself with the code which is in the slides and see what you missed, see why you didn't think of that, and then do it again, and then do it again until you manage to do it. Not by learning it by heart. Don't learn it by heart. Don't learn which part of code follows which part of code. Learn to think. Learn to examine the problem as a collection of parts which you need to assemble together and which you need to build. You need to build each part and then assemble these parts together. That's how you solve programming tasks. Anyway, now we already saw how to branch our program, and that's a very important part in coding in order to have something more complex than a calculator and something that actually reacts to input. But how do you handle code which needs to execute multiple times? So let's say you want to print the numbers from 1 to 10. Well, what you do is you use a loop. Now, you'd probably say, okay, well, I can actually print the numbers from 1 to 10 without using a loop. I can just, let's get rid of this code. I can just say system.out.print line 1, and then I could do print line 2, and then I could print line 3, and then I could print line 4, and so on until I reach 10. So that's a valid way of printing the numbers from 1 to 10. So what do loops give me? Okay, so they're another part of Java and of programming languages in general, which allow me to repeat some code. But why do I need to repeat code with a loop when I can do it manually? Well, first off, manually really doesn't, look very well, because you just have repeating of code and repeating again and again and again. And second, it actually can't achieve everything you want. So if you don't have a loop, you have no way of reading a number and executing a piece of code that number of times. Like, I guess you could do something like read a number and number to which we want to print. So max number. So let's say we read that max number from the scanner, and then we print until we reach the max number. So you could hack it. So you could say int current number equals 0, and then if current number is less than max number, well, system.out.println print that current number, and then increase that current number, and then write another if which is exactly the same, and another if which is exactly the same, and another if which is exactly the same, and so on and so on and so on. But do you know when you need to stop? Well, if you know what the max number could be, and let's say if it's 100, you could repeat this if statement 100 times, and yeah, that would probably solve the task, because none of the following if statements will execute. You will only execute as many if statements as increments you'd need. But that really isn't ideal, because that's only if max number is 100. Well, if it's 1,000 or 100,000 or 4 billion, that this could be a very large number. So, and it's really hard to write code which executes a fixed number of times in the program. Also, it's not efficient. If you have 4 billion as the maximum possible number which could be entered on the console, you need 4 billion ifs, which would create a pretty large program. But in addition to that, running that will always do the 4 billion operations. Whereas if you do it with a loop, with a structure in Java which allows you to execute a variable number of times, variable meaning a number of times coming from a variable instead of non-compile time like this code is, that loop will only execute as many times as you need instead of 4 billion each time. Okay, so loops are actually if statements that repeat themselves. So a while loop, let's use the while loop. A while loop is just what we wrote previously. So the multiple ifs chained one after another. So we had an if, and then we had another if, and then we had the same if, and the same if, and the same if, and the same if, and the same if a lot of times. Well, that's exactly what a while loop is. Oh, however, you don't write it multiple times. You write it exactly once. Oops. Let's return to the while loop version. Okay, let's delete this if. Now, instead of writing multiple ifs one after another, you just write while. What does while do? It checks for the condition, just the same way an if statement does, and executes the code if that condition is true. But then, instead of continuing the execution of the program after the end of the body of this while loop, it returns to the condition again. The if statement doesn't return to the condition, while the while loop returns to the condition. So the while loop is exactly the same as the if statement. However, instead of continuing on, it returns to the condition. And the while loop has no else, obviously. Okay, so it returns to the condition and checks the condition again. Now, if we read a number like this and we start this program, what would we get? We'd get the number starting from 0 up until that number printed out, up until less than that number actually. So if I enter 4, I'd see 0, 1, 2, 3. So here's what I get. I enter 4, I got 0, 1, 2, 3. Again, only focus on the dark part of the output, ignore these blue messages from the debugger. Okay, so that's what that's what a while loop is. It's just an if statement which repeats its check until the check becomes false. As opposite to the normal if statement, which just calculates the expression once, and if the expression is true, it executes it. So yeah, an if statement that returns to the check. So that's how while loops work, and they're the simplest type of loop. So what are loops actually? Loops are so-called control statements, the same way that the conditional statements, if and else, are control statements. They control the execution of your program. An if statement branches your program and does one thing or another thing, whereas a loop does one thing if the condition is true, and then repeats to check the condition, and if the condition isn't true, then it breaks out of that loop. Okay, so that's what a loop does. And there are several versions of loops. The most popular version of a loop is the for loop. The for loop is actually a bit more complicated version of the while loop, meaning it's a while loop, but it has an initialization and an increment automatically added into it, whereas the while loop, you just continue on until something happens. So for loop, those are generally used for doing something a fixed number of times. Like in our case, we have a fixed number of executions which is clear at the moment of input. So when the user enters this number, we need to execute our code that amount of times. So a for loop is ideal for that purpose, whereas while loops execute until a condition changes to false, which is what the for loop also does, but the for loop is sort of designed for fixed number of times iteration. And the for loop and the while loop are completely interchangeable. You can do anything with the for loop with the while loop and vice versa. And there's also the do while loop, which is only different from the while loop by the fact that it always does something and then it checks. So it will execute at least once. So in our case, a while loop will first check the number, whereas a do while loop, do while, and the while goes after the body of the loop. If we now enter 0, the do while loop will print 0, whereas the while loop will not print 0 because it will immediately check this and not enter the loop. So if I start this, the do while loop will print, if I enter 0, it will print at least 1 0, meaning it executes at least once, whereas the while loop, the simple while loop, will not print 0 because it will immediately check, okay, current number is equal to max number, so it isn't less than max number, so this is false, so we continue on after the loop. Okay, let's test that and see that that's how it behaves. We enter the number 0 and nothing gets output on our console. Okay, so that's the difference between the while and the do-while loops, and do-while loops aren't really that used. The main usage of loops concerns while loops and for loops. Do-while loops they're a bit weird to read, and that's part of the reason they aren't used a lot. It doesn't mean that you shouldn't use them, but in most cases you would find yourself preferring the normal while loop. Okay, because in most cases you actually need to do a check before you do something. Just like the if statements. You don't do something, then do the if statement, then do it again. That's what the do while loop does. There are some specific situations in which you would want a do while loop, but anything you can do with a do while loop, you can also do with a while loop by just repeating the code in the while loop's body. You know, this code right here is the exact equal to the code do while and leave only the method, the loop body, do while and so. So your main approach to writing loops will be either write a while loop or write a for loop. Now, what is a for loop? A for loop is just something that is built to execute a fixed number of times, starting from an initial position and ending in a specific position, and doing that and incrementing the variable it uses to iterate on each execution of the for loop. So a for loop is just this while loop, which we just implemented, is absolutely equivalent to writing the following. For int current number equals 0, current number less than max number, current number plus plus. And I'll unzoom a bit and hide these a bit. Okay, so actually we don't need this project pane at all, so I can hide it. Okay, so now it highlights the current number over here because I've already have a current number initialized up here for the while loop, so it can't allow me to create the same variable name. But otherwise, if this while loop didn't exist, this code over here is absolutely identical to this code over here, with one small exception. The current number variable here declared here is visible after the loop finishes, whereas a number initialized inside the for loop is not visible outside the for loop. So this exists for the entire execution of the for loop, but it's not accessible outside it. Okay, so this is a for loop. A for loop has an initialization, it has a check, and it has an incrementation. And this part is executed last, after the body. Just like it is executed last over here in the while loop. The body is before it, so here we have the body, and here we have the for loop's body, and this current number plus plus is executed after the body executes. And that's how the for loop works. The point of the for loop is when you have a specific range of values which you need to iterate, that's how you do it. The typical way would be to do a for loop. You use a for loop whenever you know the number of iterations and it doesn't change, whereas a while loop you do if you need to execute operations on some data until that data changes in some way. Okay, so that's the for loop, and this, of course, I'm missing the printing part, the actual body. Now this code is exactly equal to this code, with again the exception that the current number initialization over here is only visible inside the for loop if it's a for loop, whereas the current number initialization here is visible in the entire main method. Why? Well, because it's outside the while loop. Okay, so that's how the for loops work. You have initialization, which gives the initial value of the so-called control variable of the loop. Then you have a check. This check can be anything. It usually is a range check. It checks whether the control variable is less than something or larger than something. And this part usually increases or decreases the control variable, but these two can be anything. This can be any expression, which changes the control variable, or it can be no expression. You can miss this entirely, In that case, your loop will probably never finish, but you can. And this part over here can be any Boolean check. Just like you can add any Boolean check in an if statement or in a while statement, you can do that in a for statement over here. So any check over here is valid, but usually your check will involve the control variable of the loop, and will probably include a range check for that control variable. Okay, so let's print all the numbers that are divisible by 3 and all of them from 1 to 100. How do we do that? Well, it's a pretty simple task. We can do it with a while loop and we can do it with a for loop. So how do we do that? Well, we have our current number. Let's ignore this max number, or we can just say max number is 100, right? Because we're going from 1 to 100. Actually, since we're checking like this, let's say 100 plus 1, because we want to reach to before max number, just like we're doing over here. Okay, so until we reach max number, how do we print those which are divisible by 3? Well, we simply do if current number divided by 3 gives a remainder of 0, so that means it's divisible by 3, because 3 divided by 3 is 0, and 3 divided by 3 gives a remainder of 0, and 6 divided by 3 gives a remainder of 0, and so on. So that's our check. And what do? We just print the current number. We only print the current number if it is divisible by 3. If the remainder when it gets divided by 3 is 0. Okay, and how do we do that with the for loop? Well, we do the absolute same thing in the body, but we have the initialization inside our for loop and the incrementation inside the for loop instead of at the end of the body. And our task wanted us to print everything from 1 to 100, not from 0 to 100, so current number would start from 1. So this is the while loop solution, and this is the for loop solution. And since it includes the max number 100, I'd actually prefer not doing the plus 1 over here, but actually doing less than or equal to max number over here. Now, you've already seen loops in one way or another up to this point, so we won't be chewing on them much more, but here is the solution to this task. We have 3, we have 6, we have 9, because that's how the for loop works. On each iteration, it increases the current number and then checks. Actually, it starts from the initialization, so it checks. It starts from current number equals 1, then it checks the condition, and then it goes to the body, and then it increments the current number. So this part is last. So if you write a for loop like this one, it would be exactly the same if I remove this current number incrementation from here and place it at the end of the body. It's absolutely the same. That's what Java does. It takes the code you have over here after this semicolon and places it at the end of your body. That's effectively what it does. Okay, so this is what our for loop does, and you can achieve the same result with a while loop, just as I showed you a few moments ago. Now, instead of writing an entire for loop, what you can do is you can say for I. You can just type in for and then use the suggestion for I, press enter, and this creates a for loop for you. And then you can just fill in the blanks which it left behind. Now, my suggestion is don't use the auto-generated code. Write the code yourself, because you need to be able to write a for loop without thinking. It should be automatic. The same way when you're learning to drive a car, your driving should be automatic, and in turning the wheel, pressing the accelerator pedal, and so on. So for now, try to type a lot, because typing a lot, first of all, increases your speed of typing, which is important when you're in a hurry. And second, it teaches you to not think when you're implementing loops and conditionals and so on. It needs to be automatic for you to write code quickly. Okay. So when you type in for I, if you're in a hurry for some reason, you can use this template for live generation of a for loop. Okay, another task. We have a program which should print the first n odd numbers and then print their sum. Okay, how would we do that? Well, since we're doing n odd numbers, that's a fixed number of odd numbers. Okay, so how would we do that? Well, my solution would be the following. If I get 5, I know that I need to execute my loop 5 times, so that's what I'm going to control based on. So I'll start from the 5 times execution, and then I'd figure out which the odd numbers are based on where I am in my execution. So what does that mean? That means that if I have n entered from the scanner as an integer, what I do is I'd start a for loop which simply executes n times, meaning it will start from 0 and end at n. Okay, and how do I handle it from here on out? Well, I need to find that odd number. How do I find that odd number? Well, there are a lot of ways to do it. One thing I can do is keep track of the current odd number. You know, have this current odd number, and which is the first odd number? It's 1, right? And what did I also need to keep a track of? I need to keep a track of the sum. So I need a sum which starts from 0 and the current odd number which is 1. And for each iteration, what I do is I'd say the sum is increased by the odd number, meaning that we add the odd number into the sum. And then the odd number needs to change, right? I need to go on to the next odd number. So how do I go on to the next odd number? Well, I just say odd number plus equals 2, meaning increase odd number by 2. Why? Well, because odd numbers are 2 apart. So 1, 3, 5, 7, 9, and so on. So getting from 1 to 3 is an increment by 2. So I increase the odd number by 2. Oh, and I also need to print that odd number. So system.out.println that odd number. Now this is one way. Another way is to just use the mathematical formula. So what would the mathematical formula be? Well, I have I, and I times 2 plus 1 will give me that odd number. So for execution 0, I will have 0 times 2 plus 1 equals 1. For 1, I'd have 1 times 2, which is 2, plus 1 equals 3. And then for 2, I'd have 4 plus 1, 5. And then for 3, I'd have, you get it, 6 plus 1, 7, and so on and so forth. So that's another way to do it. And again, how did I think of this that quickly? I haven't thought about the solution before I just saw the task. I just thought it up on the spot. How did I think it up on the spot so quickly? Well, I have implemented a lot of loops. At some point, you just get an intuitive feeling for what the loop should do. You just need to solve a lot of these programming problems. And initially, it's going to be a bit slower, but from then on out, you will start figuring it out. But the main thing you need to do is focus on the number of executions and determine your operations based on that execution on which you're on currently. Okay, so this will solve the task, and I can print the output system.out.println. I already printed the number, and now I only need to print. I'd actually print formatted, and that format will contain some column and then the digits and a new line of that sum, which I just calculated. So starting this again, I will enter 5, just like we have in this example. So I'm entering 5, and I see 1, 3, 5, 7, 9. Okay, that's 5 executions, correct? And the sum is 25, and as they have described for us in this PowerPoint slide. Okay, and I test for 3 and so on, but I won't be doing it now. Now, what I'll show you, in addition to this solution, is a for loop can have multiple initializations, and it can have multiple increments. So, what I can do is, since you see that I'm using that odd number too, it changes the same way the control variable of the loops changes, right? It increments on each iteration, and it increments at the end. We've already used it. We can consider this part the body, and this part the increment, we've already used it with its value, and then we increment it the same way we do for I, right? And the initialization is only once again the same way we initialize for I. So what I can do if I want, although this is a bit harder to read and I don't really suggest you do it, but you can. So if you initialize I like this, you can also place a comma here and initialize odd number here equals 1 and remove it from over here. No, or maybe I misled you. Okay, so maybe we can't, oh, no, we should be able to, let's see, yeah. You place a comma over here, and then you initialize another number of the same type. That's your limit. You need to initialize variables of the same type. So you initialize I with the value of 0, and you initialize odd number with the value of 1. And over here, we can do odd number plus equals 2. And you can remove it from here. So summary, you can add multiple initializations and you separate them with a comma, but they all have to be of the same data type. And you can do multiple increments and you separate them with a comma. Now this is a bit harder to read, but I demonstrated what it looks like by writing it the first time. Now I just compacted it into the for loop. None of these is faster or slower than the other one, or at least not significantly so based on the input. So my suggestion is use the first option if you're going to solve this task in this way, and avoid multiple initializations in a for loop and multiple increments in a for loop. But keep in mind that you can do this. So I'm showing you this way of coding a for loop because you might encounter it somewhere, not because I'm endorsing you to do it. My suggestion is don't. My advice is keep the body a body and keep the increments only for the control variable of the loop. Okay, so that's how our for loop works. And let's continue on. We solved this task. Let's continue on to whatever we have next after this. So I already introduced you to the while loop, but just to recap, a while loop is something that executes until a condition changes. So it executes while a condition holds true. In this case, this condition will hold true 10 times. Why? Well, because n is 1 and the condition is n less than or equal to 10, and n gets incremented in the while. Now this is the equivalent of a for loop, which starts from I equals 1, continues until I is less than or equal to 10, and has an I++ in it, and does system.out.println does this operation over here. That's a while loop, and while loops are usually used when you operate on some piece of data until it changes. For example, one thing you can do with a while loop, for which a while loop is good, is printing out the digits of a number. So how do you print out the digits of a number? Well, let's do it. It's an interesting task. So let's read the number from the console. Let's call it number. And let's read it from the console and let's print out its digits separately. So we want each digit on a separate line. Now, starting from the last digit. So if we get the input of 142, what I want printed is 2, then 4, then 1. So print the numbers in reverse. How do we get that? Well, we can do the following. We can say, while that number is larger than 0, we will do the following. We will tell the number to give us the remainder of that number divided by 10. What is the remainder of a number divided by 10? Well, that is the last digit of the number, because in our numeral system, our decimal numeral system, what happens if you have 142? If you divide it by 10, that gives you what? 14. 10 multiplied by 14 equals 140. And we have a remainder of 2. So 10 times 14, 140, plus 2 equals 142. Okay, so this is the remainder. So 2 is the remainder. If we do 142% 10, that gives us 2. Okay, and then if we say 142 divided by 10, that gives us 14, and we've just removed the last digit. So using %10 gives us the last digit, and dividing by 10 removes the last digit, so it removes this too. So this operation of division removes the 2, and it leaves us with just 14. So what can we do? We can repeat this operation now and do it for 14 and get by 10 the remainder when it's divided by 10, and that would give us 4. And then we do 14 divided by 10, so we get 1, and then for 1 we do get the remainder for division by 10, and that would be 1, and then 1 we would divide by 10 and we'd get 0, and for 0 there is nothing more to do. We stop it here. So that's why I said, well, we will start a while loop which continues until the number reaches 0. Now there is a catch here. We need to have an additional check. If the number starts from 0, we need to print 0 because the digits of 0 are 0. So there would be another check over here which says if number equals 0, then just system.out.println 0. Print at least one digit for this number. Otherwise, if it isn't 0, just start printing the digits. So while number is different than 0, while it's larger than 0, and that would work for positive numbers, of course, but it would actually work for negative numbers too. It's pretty much the same logic. You can test it out so you can see for yourself. Okay, so the last digit is the number divided by 10. And from here on out, what do? Well, we print that last digit, system.out.println the last digit. And now we need to change the number so we get rid of the last digit. We already got it and printed it. Now we want to get rid of it. So we just say number becomes number divided by 10. And if I start this program, it will continue until it displays all of the digits of number, and then number will reach 0 and the while loop will stop. So if I enter 142, I just got 2, 4, 1, and the program ended after that. So that's how you split up a number by its digits, and that's useful for when you need to convert it into, for example, a string, or if you want to encode its digits in some other way. Okay, so that's usage for the while loop. While loops are usually used when they process some part of data, some part of information, some piece of information, and change it in some way, so they need to recheck what happened to that information. That's a pretty vague description, but we need more specific tasks so we can see more specific examples of that. Okay, so we have another task over here. We need to implement a multiplication table. What do we need to do? Well, we need to display the multiplication of a number by its multiplier. So we have a number we read from the console, and then we need to display all multiplications of that number from 1 to 10. Well, how would we do that? I'd actually do that with a for loop, not a while loop. But we can also do it with a while loop. We read the number, we start from times equals 1 and continue until times reaches 10, and then just print the number, the multiplier, and then the number multiplied by the multiplier, and then we need an increment somewhere over here, right? Because right now, does times change? No, it doesn't. So this code will actually execute an infinite number of times. This code over here has a bit of a catch to see if you're paying attention. So this code will execute an indefinite number of times because we aren't incrementing this times variable. So there should be a times plus plus somewhere. I'd add it at the end of the while loop. Or I just use a for loop which starts from times equals 1 and reaches times less than or equal to 10 and does times plus plus on each iteration. Okay, oh yeah, so here's the catch actually. I showed the part of the code up to here, and then here's the catch. If you don't do the times, this loop will execute an infinite number of times. Here, however, since we're incrementing the multiplier, and that's what we check for the range, well, that's the reason this while loop will actually terminate at some point. Okay, so that's one way to do the multiplication table. Again, I'd prefer the option with using the for loop. Okay, and the do while loop is just something that does operations regardless of, so it's the same as a while loop, but it always executes at least once and then it checks, and then it executes again, and then it checks and executes again and checks and so on. Whereas the while loop first checks and then executes. Okay, so we have another version of the multiplication table where we have the number of multiplications we need to display is entered from the console, and this is pretty much the same task but done with a do while loop. So this will always print at least once. So even if you enter times starting from 10, you would still see actually times starting from 11. If you enter times starting from 11, this do while loop will execute once and display the number multiplied by 11, whereas the normal while loop will not do that. And it really depends on what task you're solving, whether you really want that printed or not. Actually, our example with the with the division continuing until the number reaches 0, the case for 0 can actually be omitted if we change this into a do while loop, because for 0 it will still print the last digit. So you can play around with making this into a do while loop. That's one application of the do while loop. Okay, so now once we've talked about loops enough, we have the finishing part of this lecture, which is how do we debug code. Now, what is debugging actually? Now, we've done it in this lesson already. Debugging is the process of finding errors in a program and fixing them. And it's pretty important that you notice the first part of debugging. As I said, finding errors. A lot of people, when they start learning programming, start by trying to fix an issue. You know, you write a program and it doesn't work, and your immediate thought is, I didn't write something correctly, let's change this line of code. But you still haven't actually found what you didn't write correctly, what you didn't code correctly. So always keep in mind that there is no such thing as a correct and incorrect program. There is a program which does what you want it to do, and there's a program which doesn't do what you want it to do. Programs always do what you told them, so they do exactly what you wrote, but that doesn't mean that you wrote what you needed to write. So where am I going with this? Well, when you have some code execute and it doesn't behave the way you expected, the reason for that is that you didn't code it correctly. So you shouldn't start changing stuff. You should find why does it do what you don't expect it to do. So when you're searching for errors in your program, you're actually searching for code which you entered, which does something different than the thing you expected for it to do. So programs don't make mistakes, programmers make mistakes. So don't think of your program as something that's doing something wrong. Think of your program as something that is very explicitly following your instructions and doesn't really know what it should be doing. The program just follows instructions. It doesn't understand what it means to solve a problem. So when you want to debug your application, when you want to find errors in your application, what you need to do is find out which part of your code doesn't behave the way you wanted it to behave, meaning which part of the code you didn't implement correctly in relation to what you wanted to happen. So for your first part is finding where the error is. So actually the first part is noticing that something isn't correct in your, for example, output, and then you need to find which part of the code causes that error in the output. And when you know that, you can start fixing that code. And always when you're fixing something, think about, if I change this, will I affect something else negatively? So any change you make to code that already exists, you need to consider whether that change will break something else in your code. And after you've done the fix, you start testing, and in addition to testing whether you have fixed the problem you noticed, you also have to test everything else which you know works, because you could always have broken something that previously worked with your fix. And debugging is pretty iterative and repetitive, and you just do it. There's a joke in programming that 90% of the program is written in 90% of the time, and then the other 10% of the program is written the other 90% of the time. So you always waste more time than you expect, because you have debugging, because you can't foresee what errors you're going to introduce into your code while you're writing that code. So always leave yourself a lot of time for debugging, even if you're very sure of what you're coding. So there can always be bugs. You by the way, you probably have noticed that in the tasks we solved, I repetitively missed adding the new line symbol at the end. Now, that's a small issue, but it's still an issue, and I saw it, and I knew what was causing it, and I fixed it. So even if you're an experienced programmer, you will still be doing debugging. Debugging is 50% or more of the work of a programmer. Writing code is fast, actually. Once you get the hang of it, writing code is fast, debugging isn't. It's just something you get better at, because you start getting better at finding errors. That's the slowest part of debugging. And once you get faster at that, fixing them is a bit easier, but it's always going to take time. So don't get disappointed if initially you're having a lot of issues debugging your code and writing programs that work correctly. That's actually good for you, because you will teach yourself debugging. No one can really teach you debugging as a concept. We can just show you what it is and how you do it and how you can use the tools in IntelliJ to do that. But it's really up to you to do a lot of debugging and examine the state of your program a lot of times in order to find errors, so you can really learn how to effectively debug your code. Okay, so IntelliJ has what's known as a debugger. Now, what do debuggers do? Unfortunately, they don't fix your errors automatically, but what they do, it should really be called a state examiner. A debugger is something that examines the state of your program. So if I place a breakpoint over here and I start my program in debugging mode, that starts the debugger, and that will stop the program at this breakpoint after I enter my input, because there is no breakpoint up to this point. So I enter my input, which is 42, and the program stopped over here. Now I'm in the process of debugging my program. Now, again, it really should be called examining the state of the program during its execution. A debugger is simply a tool which can stop your program while it executes, and it can display information about the data in your program. So in our case, this IntelliJ process seems to have failed for some reason. But what we do is we place breakpoints, and once I think I know what caused the failure over here. Let's start it again. Once we have some state in our program, in this case the state is all of the variables that are visible at this breakpoint, we can examine that state. So if I had an error, well, what's the usual case for an error? Well, some of the variables which I have don't have the correct value. That's what an error is. In programming, an error is simply a variable in your code does not have the correct value that it should have had at that point. And once you find which variable that is, you just check what changes that variable and where did it get that wrong value, and then you just start searching. So you notice one variable that isn't correct. Okay, you see how that variable is calculated, and then you see the variables which are used for its calculation. Then continue on to them and examine at each step, and at each step again, and at each step again, and see if you find something that isn't correct in the code itself. And you usually find that by just looking at values of variables. You think of what should the value of the variable be at this point of the execution of the program, and if it isn't that value, well, what causes it? And then you find the code which causes it and you fix it. Okay, so what does the debugger offer you? Well, it offers you this exact thing. It offers you examining values. Now, a moment ago, my debugger froze. Why did it freeze? Well, because I had a line which I added in the start of the lecture, which was scanner.next, right? I had this in the variables over here as an expression which gets evaluated. Well, the debugger froze because it couldn't evaluate this because I wasn't entering any input, because this reads from the console. So be careful with expressions like this one. I'd suggest that you don't add something that reads from the console directly as a variable here, but definitely use the variables which are already listed. These are the values of the variables you're looking at right now. Now, if I place a breakpoint over here and press F9, we will reach this breakpoint, and I will also have another variable over here which is last digit. So if I had an issue with my code which was finding the digits of my number, well, I'd look for it here, because if I wasn't getting the digits correctly, let's say if I didn't do the correct division, then I'd see that last digit was 0 if the division here was non-remainder division. If it was just division, I'd see that the last digit is 0, and I'd ask myself, okay, so number is 42, and I'm dividing it by 10 and I'm getting 0. It's actually not 0, it's 4 in this case. It would be 4. So last digit is 4, and I'd say, okay, so I have 42 and I'm dividing it by 10. Why am I getting 4? Well, I'm getting 4 because that's what I'm telling the program to do. I'm telling it to just divide by 10, which is 4. But what I actually want is to get the remainder of that. So that's one way I can find an issue. If I had an issue over here, if I had used the incorrect type of division, well, that's how I would find it. And if I had used the incorrect type of division over here, or if I forgot how to if I forgot to add this line, well, I'd add a breakpoint over here and I'd say, aha, so I'm not reducing my number if this line was missing, and so on. That's the process of debugging. Debugging is just placing breakpoints, telling your program to continue to the next breakpoint, and examining each variable. Is the variable which I'm looking at containing the correct value it should be at this point of the program? And if it isn't, what's causing that? And if I can't find it on this run, since I've skipped over it, well, I stop it, and then no, okay, this variable didn't get the value correctly, so I'll place a breakpoint earlier. If here it was already with the wrong value, well, I'd probably need to look for the reason for the wrong value in the start of the program. So that's what debugging is. It's just jumping around places in your code, using the debugger and navigating between breakpoints. How were we doing that? Well, we place a breakpoint where we want the program to stop, actually to pause, and then we just continue on to that breakpoint. If it's the first breakpoint, we just start our program, enter our input, and so on. And then when the program stops at the breakpoint, we examine the state of the code in this variables window. Notice, by the way, that when you go into debugger mode, the console gets hidden. This is the console. There's a different tab for the console, and you can go back to it by clicking on this tab down left here. Okay, so you can switch between console and debugger through these tabs. Okay, and then you check in the variables window what variable has what value. And you can even write expressions. I showed you that you can do, for example, number plus 10 and see what that does. Okay, so this is what debugging is. It's simply going around in your code, checking values of variables, and deciding, is this value correct? And if it isn't, how can I fix it so that it can become correct? Okay, so that's what we need to know about debugging, at least up until this point. Now, another thing which would be nice for you to know. If you start a program and that program doesn't finish, for example, that would probably mean that you either are waiting for input somewhere or you have an endless loop somewhere. Now, one thing you can do is use this pause function. What that does is navigate you to the current position in the Java execution where the program is located. Now, once you do that, notice that we ended up in some file input stream class, and we got paused over here. Okay, so how do we find where that is in our code? Well, we go back to the debugger, and you look at this frames window, the left part of the debugger, and all of the yellow text here are internal Java functions. The first non-yellow backgrounded text is the place in your program where this is located. So if I click here, I can see that, so this read bytes function, which I was sent to earlier, is part of scanner.nextInt, because look, in main, someone called nextInt. That's how the sequence of calls in programs work. We will discuss that in detail when we get to talking about methods. But this is how the sequence of operations works. You have main, and then on top of that you have the call to nextInt, and that calls something else, and that calls something else, and so on and so on and so on. And if you pause the code somewhere like we did, you get to the bottom of where it was paused, where it's waiting for input in this case. And if you want to find your part of the code, you just find the topmost white background in these lines and select that, and that would navigate you to the position where you stop the program. So if you're searching for which while loop didn't end, well, if you're seeing a program which you've entered all the input and it keeps executing it and it doesn't print anything, you probably have an endless while loop or for loop or something. And then you just examine with the debugger, you pause the code and you see where you're located. And then you can figure out, okay, so why doesn't this end? Well, what are the variables, what are the values of the variables currently? What should they be? Which variable doesn't have the correct value? Why is it getting that incorrect value, and so on. Okay, so IntelliJ has this debugger. It has these breakpoints which allow you to tell the program to stop at certain location, and it allows you to trace what happens after what, meaning you can jump around breakpoints. There are also other features like jumping over parts of code and jumping into parts of code, but really you would mostly be using the breakpoints. At least that's what I do. I just place breakpoints where I want my code to stop. And the most important aspect is it allows you to inspect what values you have in the variables at that point in time. Okay, so there are shortcuts for starting without a debugger. Over here you have this button starts without a debugger. This will not stop at breakpoints. The bug symbol over here will stop at breakpoints. This is starting with the debugger. Okay, so F8 would just continue your execution of the program from the position you're located. You can add stuff like conditional breakpoints too. So you can add a breakpoint, and you can tell this breakpoint by right-clicking on it. The condition for this breakpoint is if number, for example, is less than 0. Only then stop at this breakpoint. Don't stop at this breakpoint in any other condition. Now, this is something you won't be adding regularly, but it's something you could use for... conditional breakpoints are actually used when you have a lot of executions of, for example, a for loop, and you don't want to stop on each one of them. You only want to stop on a specific execution of a for loop, for example, when the index is 5 or when the index is 130 and so on. Okay, so let's examine this program and find what the bugs in it are. I'll copy the program and I'll paste it into my main method. And I'll try to find what causes this program to run incorrectly. Now, what's the point of this program? Well, it should find the first n odd numbers and print their sum. So this is the task which we were solving a while back. Okay, so what does it do? Well, let's try some input for this program and see what it doesn't do correctly. Okay, so let's input something which we already know. Let's start it and input something which we already know. What is that thing that we already know? Well, we already know that the sum for 5 was 25 and the numbers were from 1 to 9, right? So 1, 3, 5, 7, 9, those are 5 numbers, and the sum of those numbers is 25. So what gets printed? Well, 1, 3, 5, 7, 9, 11, and the sum is 31. Okay, so there seem to be a lot of errors over here. So when you can fix something simple, start by doing that. What's the simplest thing we can fix? Well, all of these are printed on the same line. So we can find that pretty quickly. We don't need debugging for that. So we need print line over here. Now if we start this program again, we can test it and let's see if it works better than previously. Okay, so now it goes 1, 3, 5, 7, 9, 11, and then 31. Okay, so why does it reach 11? So the first issue over here we have to solve is, why does this program reach 11? It should print only 5 numbers, but instead it's printing 6 numbers. Okay, so how would we check that? Well, we place a breakpoint here, we start the program, and then we check each of the conditions which happens. So the first condition, first we need to enter 5. So initially we can see that I is equal to 0 and n is equal to 5. So that seems correct. And then we're continuing. I is 1 and n is 5. So let's see how this will, since I started from 0 and n is 5, I should reach at most 4, right? So 0, 1, 2, 3, 4 are exactly 5 executions. And we want exactly 5 executions. So we should reach at most 4. So let's see what happens. I becomes 2, then I press F9 again, I becomes 3, and it stops at this breakpoint again. Then I press F9 again, and I becomes 4, and then I press F9 again, and lo and behold, I becomes 5. This is the 6th execution. Now, do I want the 6th execution? Well, I want exactly 5 executions, and notice how I'm adding numbers. I'm using the formula 2 times I plus 1. So for I equals 0, actually I can calculate it. I can say, okay, place this expression inside this variables window, and let's see what that generates. Okay, that generates 11. That's the number I didn't want generated. Okay, so I should have placed this actually in the beginning of the debugging process, so I can see what value is what. Okay, so I get 11 and I get that printed. So I don't want 11 printed. So why am I printing 11? Well, I'm printing 11 because I becomes 6. I becomes 5. So I should never become 5 because it started from 0. And if I was 0, so if I get this expression, I copy it and I replace I with 0, that's the correct value for the first odd number, right? So for I equals 0, this is the correct value. So the formula is correct. The thing that isn't correct is I. I is 5. And it shouldn't be 5. It should never reach 5. It should start from 0 and reach 4 inclusively. Since, why should it reach 4 inclusively? Well, since we have 5 executions and the number of numbers from 0 to 4 inclusively is exactly 5 numbers. Okay, so why are we reaching 5? Well, if we're reaching I equals 5, since I is the control variable of the loop, one reason for reaching it might be that our condition wouldn't be correct, or our increment isn't correct, but the increment looks correct. So what remains? Well, the condition. And yes, if we look at that condition, if we copy it and if we paste it over here, we'll see that that condition is true currently for I equals 5. Why is it true when it shouldn't be? Well, because we're using less than or equal instead of just less than. Okay, so we're changing that. And we're going to start the program again and see if the issues are fixed or if there are other problems. Okay, so we enter 5 and we got 1, 3, 5, 7, 9. So the output for the odd numbers is correct, but what isn't correct is the sum. So I have 21 as the sum. Why do I have 21? Okay, so let's do this again. We'll place a breakpoint over here and we'll see what do I print and what do I add into the sum. Because I know that the sum isn't correct now. So the sum should be 25 if you remember from the last example. So we're going over here and okay, let's see. I'm printing the correct number. So I know that this is the correct formula for the current number. Am I adding this to the sum. Well, no, I'm not. I'm adding something different. So I don't need to debug any further because I see that I'm printing one thing and I'm adding another thing into the sum. Now, if you're going to be adding the same thing to the sum and to the printing, well, don't have two expressions, have a single expression. Mark the expression, say Control-Alt-V, that would extract a variable, and I'd call this the odd number. This is my odd number which I'm adding. So the issue over here was that I wasn't adding the correct number to the sum. I had the formula copied, but I didn't copy, or whoever wrote the code didn't copy the entire formula or didn't code it correctly. Maybe they coded it once and then they tried to write the same thing again, but missed adding the +1 over here. Okay, so let's try it again. Always when you're reusing some expression, you should, well, not always, but almost always when you're using some expression, you should have a variable for it. You don't need to write it over and over again. That's what variables are for. Okay, so let's enter 5. Okay, so now we got 1, 3, 5, 7, 9, and the sum is 26. Why is it 26? Well, we know that we're adding the correct numbers because we're printing the correct numbers. So the only reason for the sum to be incorrect is if it's not in the loop. That's what I'm saying. It's not in the loop because what we're printing, we're also adding. So if it's not in the loop and it's not after the loop, because this is just a print, it's gotta be before the loop. And if we notice, sum starts from 1, but what should it start from? It should start from 0 because we don't know if the sum is 1. We will only have the sum of 1 when we add the first number. And that should be the last fix in our program, and that should finish the debugging session we have now. So entering 5, we'll see 1, 3, 5, 7, 9 and the sum of 25. Now notice how at each step I examined the variables which there were in the code. So if you were watching carefully, you probably noticed all of these bugs before I mentioned them, and I did too. Actually, I didn't notice this one. I noticed it at the end. But I noticed all of the other bugs previously. But I wanted to demonstrate how I go step by step into the code and look at the problem spots. So the obvious problem spot initially was the lack of new lines. Then the next obvious problem spot was the incorrect iteration of the numbers. And then the next problem spot was the incorrect sum. And that finished up my debugging. So I went piece by piece and line by line in my code. And I found each obvious problem, I found what caused it, I found the values which it used, and I used that to debug the program. Okay, so that's how you debug a program. And again, the pattern is find an issue, find an error, notice that there is an error. After noticing there is an error, find which part of the code causes it. How do you do that? Well, you start debugger and start examining values of variables. You examine the exact places where you expect there to be an incorrect value of these variables. If you can't find it, you just look for it. You go step by step in your code and look for values that don't match up with your expectations. And then you just make the changes required to get the correct values. So we talked about how we can declare variables, and we talked about how we can print them on the console. We talked about what the structure of a Java program is, and we talked that the entry point is always the main method. We talked about conditional statements and how we can branch program logic. We talked about how we can repeat code multiple times based on input from the console or any other calculation. And we saw how we can use the debugger. Thanks for listening. As always, ask your questions in the channels we have provided. And I hope this was helpful for you, and see you next time.
Did you like this lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free video tutorials on coding and software development. Get free access to the practical exercises and the automated judge system for this coding lesson and many others. Get free help from mentors and meet other learners. Join now, it's free. softuni.org